What is up, everybody? Welcome to the Ham Radio Crash Course. Welcome to Saturday. We got a big one for you today. This is the QDX build. The QDX, made by QRPLabs, is a digital-only, USB-connected radio. It operates on multiple bands, and we're going to be building it and testing it live. I'll probably also be running the radio in the after chat, which will follow the live stream. So thanks, everybody, for coming out. We'll get started soon. Please enjoy the memes. All right, what's going on, everybody? I'm gonna lower this down a little bit. Have it play though a little bit. I'll still play a little bit. You hear me all right? All right, cool. How's it going, everybody? I am Josh, KI6NAZ. Thanks for clicking on the Ham Radio Crash Course. Appreciate you taking the time out of your weekend. Kit building is a huge part of our hobby and a lot of fun. And today's kit is no different. This is, but unique. Most kits that you see these days are kits for CW, some single sideband. But QRPLabs having this digital-only mode transceiver, super cool. Now, I will mention that I did pre-wind the toroids. I will show you all of them as we go through it. You kind of have to with this kit, so this is really a light soldering kit, except for a whole lot of toroids. We'll get into it, though, as we move into that phase of the show. All right, so as always, if you'd like to help support the Ham Radio Crash Course, check out hamtactical.com. The link is in the description, along with all of the affiliate codes we run. And basically, affiliate codes work in the simple concept of go to the Amazon page. If you buy something, it helps out the channel. If you buy, however, a shirt, that goes directly to support the Ham Radio Crash Course. And we do appreciate it because it also goes to support the podcast that I do with my wife and all that other fun stuff. All righty. So, what is the QDX? Well, like I said, it's a digital transceiver. Goes for about $70, and highly recommend that you get the aluminum enclosure for it as well. That's not included in the price of the radio. However, highly recommend it. You don't just want some bare, loose radio kicking around. And for reference, it will run off of 80, 40, 30, and 20 meters, putting out roughly 5 watts of digital, or 5 watts of RF output when you're using it, which is actually pretty cool for the size of this thing, which ends up about the size of a deck of cards or so. We'll get into it, I promise. It is very cool. There are a lot of really great videos out there. In fact, Temporarily Offline has been doing a video series with his Discord group called Toads, and multiple videos they've been working on, and there's probably some more stuff coming. In fact, I'll be doing a video with Steve here probably in the future on the live stream talking about kit building, and this one is kind of an interesting one, particularly for you guys that like JSA call and FT8. WinLink, you can do all of that with this little unit, and it's literally goes in your pocket. It's really small. I'll take a moment here and say a big thank you to Bob. Couldn't remember your call sign, W1NV. He sent a little care package in on the podcast, again, that I do with my wife, Ham Radio Crash Course. You can look that up. And in that was a couple of beers. This is the High Stepper IPA. So we're going to enjoy that as we kick things off. Question in the chat from Don N5SKT. He is familiar with the radio. 12 volt or 9 volt? I'm going to have to go 12 volt because I'm going to run this with my Jankopotomus. And so I will be, or I have, already rolled the toroid in question to support a 12 volt power source. But this will also run off of 9 volts. And we will see in the instructions when we get there explicitly where that part is. So that's what I will be doing. Aluminum closure is a must. I agree. Yeah, the pro tip there is, take this little QDX, put it in its little box, and then you can use a Raspberry Pi to interface it, charge the whole thing off of solar, or have some kind of off your primary grid type setup, and then you can be doing JSA call in the background. You can do all kinds of cool stuff with it, and that's really cool. So it's a fun radio, I promise. Digital only though, so that's gonna only appeal to some of you. However, I think it's gonna be a fun build regardless. It's just like the QCX in a lot of ways, but let's just look at the PDF here. So I have a Rev 3 board. This is the most current revision, and it's the one that's available on the website. I picked this up at Hamvention a couple of months back. This is what it looks like when it's done. Literally, it's just a simple status light and a couple of interface controls on the back. There's no major user controls other than kind of farming that all out into a PC. And literally, that's 3 connections, right? Power, antenna, USB. That's what the thing runs off of. But you can probably already see it. There is a grip of toroids in this thing. There are 13 total toroids, and 3 of them are, is that right? 13, 6, 7, 8, 9. No, I'm not counting correctly. That's 6, 7, 8, 9, 10. 10 toroids. I don't know why I said 13. Anyway, 10 toroids. 3 of them are relatively unique. They're toroids that you probably have not experienced before, so I'll take my time as we get to it. And talk a little bit about them because they deserve a little bit of explaining. It's not your simple just through the hole multiple times. But with that said, not too difficult. If you can get around toroids, it's not that big of a problem. I did take some time and go through. Oh, here's the discussion on whether you want to build it with 9-volt or 12-volt operation. I'm doing 12-volt so I can work with the Jankopotomus laptop. Of course, I got to be able to use that Jankopotomus. And let's see, going through some recommendations. Here is the PCB mapping. There is a ton of ICs that are already soldered on for you. It is mainly through hole. Temporarily offline says, no, 9-volt. Is there a reason why I want to do 9-volt? Don't I want to do 12-volt so I can be super, super cool and have my laptop charging at the same time I'm running my QDX? I did go through and do a parts list check. Note, when you get your own kit, if you do decide to go down this path, the purple text are SMDs, which are surface mount parts. You're not responsible for installing those. Those come pre-soldered. However, if you would like to go and double check the work and make sure that the components are there, Hans did 12 volts. Hans is the owner of QRPLabs. Hans did 12 volts to stop the OMs from arguing about not doing 12 volts. But then there's a ton of actual components. So here's our capacitor list. And then there are a couple of MOSFETs, a bunch of diodes, 6 diodes in total, and then some, physical components as far as connectors and whatnot that will be soldering in place. All right. Here is your parts layout for most of it. You can see all of it right there. Yes, it is tilted 180 degrees off. That is a part of the PDF. I'm reading comments as we go. More pieces on the capacitors. And here's what it kind of looks like. So these are, you can see the toroids there listed. It's actually an impressive amount of toroids. We'll get into it though. Heat sinks on those finals. Yeah, that's we'll talk about that. I actually liked I watched one of Tio's videos beforehand. He had lots of tips that he provided on building this, and one of them was using thermal paste, which I thought was a completely novel approach to distributing some of that heat off of those MOSFETs. However, I just recently threw out some some CPU paste, some thermal paste. So I'm going to go look around for something that would work as a solution. But yeah, indeed. All right, so the first thing, let's see, what is it asking us to do? Okay, so it wants us to install the ceramic capacitors first. General rule of thumb when you're doing kits and anything where you're going to be soldering is you want to solder the stuff that's closest to the PCB first and then build up to taller, more proud components. And that allows you to get your fingers in there on the low ones, get them all soldered, and then move on to the higher stuff. So we're going to go ahead and start up with that right now. But I wanted to show you the little layout that I have here, and I have an extra light I'm going to set up just for this purpose, and also take a little sip of the high stepper. Ooh, high stepper IPA, pretty good. Let me slide over here. All right, so I took the opportunity to pre-roll these toroids, and I think that's going to be important for a lot of people to do that. Definitely if you're going to go on a live stream. Not everybody's live streaming, but I did. Please drop the poll. Oh, can I do that? I don't think I can hide it. I can't hide it on my end. The chat will roll up. It's fine. You're not missing anything. I have to end the poll. That's the way this plugin works. I don't think I can get around it. Let me see. I can just remove the chat entirely. Nah, we'll just leave it like that. Nice icon pad there. That actually came with the Hamvention swag pack, which I still have some left, guys. I'll figure out a way to hand these out, and I may be bringing some with me to Huntsville. So if you're going to Huntsville, make sure you say hi, and we'll sort something out there. So let me pull this over here so I can show you what I did. The traditional windings, I just wrote what their number was on the PCB along with what their windings were. These are all traditional, meaning you just count every time the wire goes through the hole, 20 turns, 24 turns, 26, you get the idea. However, there is one binocular toroid, and that's the one that actually handles the power output of the radio. It is a primary and secondary turns, so you're actually going to wind one direction and come back around and wind the other direction. And the number of winds on the second set, the secondary turns, or the secondary windings, are going to denote your power operation. So I have mine set up for 12 volts. Probably the trickiest toroid in the whole thing is this multi-tapped toroid. So it's 41 windings, and every so often you pull a little bit off extra and make a loop, and that's going to go through the PCB. So they're going to be kind of, you're basically using one toroid to handle multiple different parts of that coil, right, of that winding. And then the last one, and I forget what they called this. Basically, it's 3 wires. I'll try something. I can't remember. Somebody will tell me in the chat. Basically, though, it's 3 wires that are bundled together, and then you wind the 3 wires all twisted through 10 times, and then fan them out and do a check for with your multimeter on if they are, connected or whatnot. It is a continuity check, and that's really important because they need to go into matching holes on each side. Let's see. Trifilar? That's not how I pronounced it. I'm pronouncing it wrong. Anyway, that was the hardest one was the multi-tap one, regardless. I'm sure you guys are right on the pronunciation, or the spelling. I just don't remember what the pronunciation was. Okay, so anyway, we're gonna put these on the side for right now as we start building up our PCB. And generally, the way I do this is I've got a little iFixit tray here, and I have a PCB vise that I really like to use for doing any builds. Hey, there was a super chat. Thank you from Sledgehammer. Hey there. Took my exam test today and failed my general. Oh, sorry. Wait, let's see. Hey there, Josh. Took my exam today, failed my general, but passed my tech. All right. Good job. AT778UX, still the best mobile radio for base stations, sub $200. Sub $200. What mobile radio would I recommend? Gosh, at the sub $200 mark, you could almost go with just an Amazon 20-watter. There's $200 doesn't give you a lot to play with in the mobile radio area, to be honest with you. To be frank, if I can be, I don't really have a hot recommendation for mobile. Maybe someone in chat will, or if you are so inclined, join us on the after chat, and there will be people in there that can probably answer your question with ease. I just don't have a good enough example on mobile radios sub $200. Okay, so the first step is MTC Radio has a TYT TH7800 for $170 or something. Hey, there you go, Southern Utah Ham Radio. Take a look at that. Go check that out. MTC, Main Trading Company. Check out and see what you got in that way. I'll be honest with you. I have not done a ton of reviews on mobile radios. I find ones I like, and then I tell people to go buy those, and sometimes they're really expensive. So if you could throw a little bit more money at it, I think the 2730 by ICOM is a better mobile radio. It's a good mobile radio, but you know, it's not hitting your mark. Yeah, so the no-code tech, as I mentioned a little bit earlier when I started this out, you can see that most of the stuff's already pre-soldered. All of our surface mounts are already there. Now, it is mentioned they are... Oh, I've got it backwards right now. I'm gonna flip this over. So it is mentioned that you can do a parts check, if you will, against the SMDs and make sure that you've got everything there. Trying to be careful not to crush these. I don't like that. Not great for the vice here. Oh well. Oh, you know what? We can turn it this way. That's right. That's the other way to do this. So you're not damaging your board. Okay, like that. I find these are very valuable. These little flippy bit vices for PCBs makes life a lot easier. So you can find a spot to hold it. Come on. There we go. That's about as good as it's going to get. I don't want to damage any of the ICs. Okay. So the first thing we got to do is install these capacitors. So we're going to find C5. I haven't done a live build in quite a while. I haven't looked at the PCB actually either. So I mean, I know where all the toroids go. All right, so first one, let's find C5 and C14. And it is a 700 picofarad through hole labeled 471, which I believe are these guys. Now I'll tell you, the I've only burnt myself once. I'll tell you what the issue has been for me is these blue, I think they're blue capacitors. The yellow ones are really easy for me to read still, but man, I think my eyes are starting to go. It's starting to happen, guys. I'm going to have to get myself a good magnifying lens here. Yeah, see, it's the contrast of the blue and the ink they use. Very difficult. Very difficult to read this. So I take a light and yeah, see, those are them, 471. Anyway, this light that I'm using is a Rovi Vaughn. It's just a little, you know, flashlight, rechargeable. Anyway, okay. So we are going to C14 and C5. Yeah. It's always the first couple of ones that are a pain to find, right? Because we're looking at it for the first time, kind of. An ant. Yeah, where's my ant? There's a little spider buddy. No, it's a spider. There's a spider right there. Does this have... Let's see. Of course it does. All right. So the 471s, there's C5. That's the way to do it. I shouldn't have been trying to find it myself. Make this a lot easier for me to do it this way. Yeah, right? A physical... There's a problem with my radio. It has a physical bug, guys. Physical bug. And this one was poorly labeled on the end, so highly recommend you look at the instructions there. So that guy goes just like that. Now, for those of you that don't build kits, I'm going to lay out parts first and then solder, and I generally will splay the legs out. I'll splay the legs out to give the best hold to them before I get to the point of soldering. So, moving along. All right, what's next? We are going to go with the 390 picofarad through C6, C19. And they are labeled 391. 391. Okay, 391s are right there. Everybody's taking bets on, will this thing actually work if I can get it done? By the way, we will be completing this build. I will not end the live until I at least complete the build. Whether or not it turns on, though, that's what we're going to wait for. That's going to be the big climactic scene at the end. And 391 is up here. We will not be here all night. I can guarantee you that, because I pre-wound the toroids. We are already 20 minutes in now, so hey. Maybe only a 2-hour live stream. We'll see how it goes. All right, next. Oh, you know what? Why don't we do this? This might be the best way of doing this. Good Lord, how big is this window? I'm going to put that window here for now, and the chat will go over the top of the poll here as we go. That way you can see what I'm looking at. But anyway, next one we're going to is the 271s. There's just one of these. God, these things are just so hard to see. Okay, there's that guy. All right, 271. You can see it's silk screen on the table here on the page. Okay, next. We just did 271. Now we're going to do the 101. You got the right space for that guy? C9? C9. Yeah, okay. Just follow the process. All right, we got a 2 for 56J. Two to one odds on what? That it works or doesn't work? On no. All right. I like those odds. Nothing like doing a live build. Nothing like it. 820. This guy should be this guy. No. 820. Okay. 122. And I'm reading off capacitor numbers. That's from off the instructions there. So that must be you. Yep. Hey, you see we got a big pile of stuff there. Got almost all of them laid out, all the capacitors. All right, 121, 821. Now it should go faster. We're done with all those blue ones that I can't read the writing on. 821. Feel like I'm in a bingo hall. Yeah, guys, and I appreciate everybody having some chats in there, asking their ham radio questions and getting them answered by the wonderful people in the chat room. If you'd like some more detailed help, consider joining us on the Discord. We'll be doing a live stream after tonight's show in which we take questions. That's what we do out there. We answer people's questions on ham radio. That's our goal, or at least one of our goals. We have a lot of fun doing it, but yeah, we want to be there to help you out as much as we can. All right, 181. We're almost out of this capacitor time. Or I just placed 181. What's next? 220. 220. All right, 220. Where do you go? You go right here. Yeah, sorry about the flashlight. It's actually I don't think I need it anymore because we're out of the woods with those blue screen printed capacitors. All right, 221. Last placements here. And looks like 300. That makes you the last, which you go right there. All right, now for the time you've all been waiting for. Let's solder these all to the board. Okay. Let's get it in over here like that. Okay. My little friend is the scouring pad for cleaning the rod or the iron tip. Really important. This is actually a gang of components to solder all with the leads flying like this. I might not do it this way going forward. Too much stuff. I'm going to have to stop and prune. Yeah, getting a little crazy there. All right, let's prune. Yeah, Jake, thanks. Much easier. You see that? Are we in focus? Oh, yeah, look at that. Oh, forgot to snip some. And for those of you that are giving me thumbs up on this one, I appreciate it. Soldering videos are seldom my #1 videos, but I enjoy it. Also, trying to cram a kit into an hour is really quite a challenge. Anybody who hasn't tried it should try it. Or host a kit build. Why don't you do this? For everybody that's in a club, let's check those solders really fast. I don't like that lead there. For everybody that's in a club, why don't you schedule a kit build day for your club? I bet they'd like that. Let's see. I'll break for a question here and have a sip of beer. Question, do you happen to know the temperature of the iron you're using? I do. I think that's Paulette. I'm doing 700 right now. In fact, that's too hot. So thank you for mentioning that. Yeah, I'm going to back that off a little bit. Thanks for saying something. By the way, some kits like it if you hang on to your snipped leads from your components. So keep an eye on that. Sometimes it's a good idea to read through your the instructions for any kit you're building before you get started, because they may ask you to hang on to a bunch of those leads before just chucking them into the trash. I generally always hang on to them anyway, and then just vacuum them all up off my desk. So just to keep an eye on that. Yeah, James, exactly. I normally use 700 for redo. By redo, I mean temp solder sucking and then rework. Steve is asking in the chat, what's the recommended temp? Recommended temp anywhere from 640 to 660, somewhere around there, and you could go as low as 600. It's also going to depend on your iron. There was a question, recommended first kit. A 4-states QRP cricket. Pick the flavor of band you want, and that's what I would recommend. All right, diode time. The good news is that the diodes are all the same. But the bad news, that's not bad news, it's just the way it is. Diodes are they're monodirectional, they're polarized. Meaning they have to go in the same way on every hole, right? As long as you're following the polarity of the hole they're going into. Now, generally, the way I do diodes, and let me see if I'm in focus here for this. Am I in focus? Yeah, good enough. I like to take my needle nose pliers and fold the leg up so you're not putting any pressure on the component. Get your tightest needle nose pliers, and if you spaced it, if you gapped it right, when you go to the hole, it should just kind of fall in. Do I have that right? Yeah. Look at the line on the PCB. Oh, these are tighter fit. Okay, we'll make the bend on the next ones a little bit better. I made them too wide. Okay, so the diodes on these are a little bit more close to the body. All right, let me do that again, but this time we'll go a little bit tighter with these bends. So I am going up against the body right now to do it. These are polarized. So if you can see his buddy right there. How am I in focus? Yep, good. You can see the gray mark, the polarization mark. You're going to follow that throughout all of these. They're going to be the same alignment. So you want to make sure that you're getting it in exactly the same way every time. They can't go however which way you want them. Yeah, that's much smoother. A little tighter tolerances on this kit. Don't screw this up. This is the part where you will be resoldering parts. I'm telling you. If you, for instance, if you end up picking up a Pixie kit, if you have a Pixie kit where they align some of the components vertically, you might find yourself screwing up some of those diodes. Those diodes are also, they're always polarized, but the way they do the vertical alignment for negative and positive polarity can be a little funky. So diodes are always the one where you want to really check your polarity first before committing solder to board. Highly recommend. Joel Husker is the kit authority. He will let you know. The guy who I really like is Joe from Ham Nation. Right? Oh, my wife is coming in here. And let's make sure we got a good flush fit. Good, good, and good. Or good enough on here. I'm going to pull this one a little tighter. Good. Joe Eisenberg. That's right. He is the Joe. He's the kit builder. When he comes on Ham Nation, he always brings new kits that I inevitably go and buy. And I believe he built this right after Hamvention and had it built and was showing it to us on Ham Nation. And I really had a bug to build this, but getting COVID was not conducive to it, to getting it done. We haven't gotten to those toroids yet, guys, so hold on. You'll see them again. I think we're coming up to them, actually. I think that's the next couple of steps. And there's a lot I can talk about there. Oh, come on. Oh, thank you, South Utah Ham Radio. I build a lot of kits. I find soldering to be very zen. I feel that's why I decided to stress myself out instead of having a zen moment. Do a live stream on it. No, I really do like building kits. I like soldering. I feel there's something about just putting solder to. Let's check all these guys before we move on. Yeah, we're good. Putting solder to components just is a lot of fun. The only question that matters is, will he give it the beans? Oh, I'm gonna start it up. I got to, but at the same time, we don't know if it's gonna work yet, guys. How's my PCB layout look there? Looks good. Looks like we're matching. All right. Oh, those vertical inductors. Here we go. So let's talk about vertical inductors really quick. So these are the inductors. This is most reminiscent of like a Pixie kit. Let me lay these out here. So these are, you know, omnidirectional. They can go on the board however you want. However, sometimes to save space, we'll align them vertically. And so how you generally do that, let me get one of them here. And where do these guys go? They go like that? Okay. The way I do it, again, I like to use the needle nose pliers, and I find the side that has the narrowest jaws. So I hold it, and I go over the top, just like Stallone. Go over the top. So there's a little bend off the top of the component. I generally don't like having the metal start to bend right at where the component meets. I like it to be a little offset from that. And then you go here. And they kind of stand on their own. Just like that. They stand up vertically. All right, so I'm going to bend this guy over again. "20 minutes until the hour." Guys, I don't know that I'm going to get done in an hour. Somebody called me, tried to call me, and realized that I'm live streaming. And where's that last one go? Right there. Wow, 330-something people watching me solder. Hey, I appreciate you guys. Thanks for taking the time out of your Saturday. I hope this is fun. Or you're just getting some really good answers from the chat room, because the chat room's on fire right now. So thanks, everybody, for helping everybody else out. Reminder, Discord after chat. I'll say it a couple more times before we're done here. Feel free to join us out there tonight. We'll be talking about ham radio, answering your questions, having a lot of fun. I do have a new movie review. Highly reviewed. Probably one of the best movies I've watched in years. Of all time. That good. Who can guess what it is? Taking guesses in the chat. So this, I think, is that component that T.O. talked about, this jumped inductor here. T.O.'s going to put a video out, likely, on talking about some of his lessons learned, and I think that's the one. That inductor looks like there's a solder bridge, but I don't believe that's the case. I'm going to do a quick. Yeah, that's just the way she goes. All right, what's next? Is it toroid time? Uh-oh, no, it's the PA. Not to worry. These are also all the same. So the way they do these MOSFETs, there's 3 legs, and you put them in and lay them down. There's no complexity to it. You just slide them in like that. But you want to give enough meat on the end here so that when you lay them down like this, that's not enough. I got to put a little bit more through. They got to lay pretty flat, but you got to give them enough component leads so that you can get the screw through. See that? Flat side goes toward the board. But as you're doing it, you want to make sure you're inserting enough of the component leads, but not too much. Not too much. Jesse Horn asks, what iron am I using? Hako. The Hako, kind of their cheaper one. By the way, guys, if you'd like to know all the products I recommend, please go check out my Amazon store. There's a whole section on soldering and everything I recommend and all the little tools and stuff. It's actually not that expensive. Help support the channel. You don't have to buy from me, but it is a good, nice, tidy list that shows you how to do what to do. All right, I got a super chat from N6ARA. Hey, thank you, buddy. I appreciate it. I've had this QDX kit sitting on my desk drawers for weeks. Thanks for inspiring me to finally build this thing. Great live stream. Well, we haven't got to the toroid yet. And I'm not saying that because it's going to discourage you, but you do need to be in the right headspace to wind up these toroids. Okay? Jesus is for losers, just as I am. Says, I'm at work and watching Josh Slaughter. Either need a more exciting job or a girlfriend or both. What's that song from? Just as I... Oh, okay. No, I don't remember. Is that a song lyric? I feel like that's a song lyric. And there we go. Now, this was what was being mentioned by Don, N5SKT, and Steve on his video about thermal, adding heat sinks to these guys, adding... that little spider is like just a total... It's climbing all over me. It's trying to get on camera. Thermal paste, etc., to distribute heat, because that's where the heat's going to show up, is on these guys. Now, there is a nut, bolt, and screw, and I'm going to go ahead and take this opportunity to install that now before soldering. You don't want this to be too tight, so take your time with it. But it's a lot easier, I found, to help use this to hold the components down when soldering. I did the same thing on the QCX Mini. Not tight, just enough to hold it down. All right. Speaking of soldering iron, what is the extra thing around the iron dog? Oh, I'll show you. It's a 3D printed. It's a little 3D printed tip holder. And if you can see the iron in the background, the iron holder. Oop. Hi, almost burned myself. Almost burned myself. Oh, you can't see it on the video. Can you see that? Shoot. Anyway, that's the iron holder. That just slides over the top like that. Holds extra tips. Not needed. I find it kind of helpful. Not too helpful. Okay. So I'm going to give this just a little hand turn. That way the components are held in place. Now we're going to hit it with the solder. Good solders. Time is it? Ooh, 10 minutes. I don't think I'm going to do it, guys. All right, moving on. All right. So here's the transformer T1. That is our guy here. This. Oh. He goes like this. A little turtle man. Turtle man is what's going to basically handle our power output being 9 volts or 12 volts. And it's that section you see in red on the instructions. So there's two ways of doing this. The primary winding is the same setup. Binocular means there's two holes down the center of it, and that's how we do the windings. There's a little turtle head right there, and then you come back around to do the secondary winding. That's the legs right there on the side. So the way this all comes together is you bring all these guys down. Now I will note that I did a bit of heating of the enamel with a lighter to get it kind of softened, and then used a steel wool pad to clean off the leads. And you will have to do that. And this hole is slightly bigger for the double, and the whole thing slides in. Now it's recommended that when you solder this, you hold that down for 10 seconds, the solder iron. I will make a note. If you're looking at buying a lighter, pick yourself up a clipper lighter. Now, I appreciate mainly pot heads are the ones that know about these, but these are refillable Bic-type lighters. They're refillable, and you can actually swap out the flint on them. These are really nice lighters. I really like this one. This one's actually Remington-themed, which I believe this color is their 410 load, but it looks like a 410 shell. Isn't that cool? Anyway, all right, let's get to it. You got to get that heat on there. I am going to throw a bit of flux just in case I didn't get all the enamel off. Enamel can't be in between the PCB pad and your component. So we're going to use some flux to help transfer heat and apply a lot of solder, or just enough solder, and let the flux liquid help transfer that heat as well. So here we go. The double is the one I'm most worried about, but got a nice solder drop there. You need the enamel, but at the same time, the enamel can't get between your windings and the PCB, because it will make it so that you're not making good electrical connection to your project. So you do need to make sure that you take the time to rid the wires of the enamel. Jesus is for losers. You are not in timeout. I think there was a mistake. You're okay, buddy. Okay, so now, before I go full hog and snip the leads, there's actually a test that you can do, and we're going to do that right now. See, they talk a lot about soldering. Okay, so we're going to do a bit of a test against the spots here on the QCX. Where are those test points? Those are funky test points. Interesting. I'm going to clip one lead just to get it out of the way because it's kind of in between some of the test spots. And I have a digital multimeter here. We want to make really, really sure that that we have good connection, electrical connection. So we are going to go from here. Is that right? Oh, this one. Nope, I was wrong. Okay, A is good. B is good. All right. And A is the hole here. Yeah! Killing it! I did it. I mean, I don't know that I did the winding right, but... Now is the time for the multi-tap. So let's go ahead and get right back in there. Oh, good. Tio uploaded that video, so it's available for everybody to go check out. There's a lot of really handy tips in there. Thanks, Tio, for posting that. Now, I don't think he snips the wires. Let me check these really fast before shoving them in. Oh, he doesn't. Oh well, I think I'm fine. Anyway, that's the behemoth we're working with, which is this guy, this bad boy. So if I remember correctly, the start is start and finish. So this is the start. Okay. Now, he didn't mention specifically taking the enamel off of these guys, because this is a lot thinner wire that the solder should probably do it. So I'm going to chance it with this. I'm not going to snip anything until I get it, until we do the test, like the last one, but I'm curious to see if it'll actually work that way. Ugh, okay. Wow, this is a fiddly piece to get in. Come on. Trying to get the wire to go into the hole here is a major pain. The doubled up wires are the problems. Okay. Cool. Not bad, not bad. All right. So we've got the toroid placed, and we're going to go through and solder here. Now, I'm glad I put my finger on there and tighten this up again because it was starting to come loose. Okay, good. He's back down. I am going to do the same kind of thing. We're gonna flux it up a little bit, a little flux, and we're going to apply a good amount of heat. I'm going to hold it not too long as we did with the other ones because those were much thicker wires. I like to go in here and give it a little, move it around a bit until it seems to stick. The biggest concern I have is always the getting the enamel off. I have done projects where I had just a hell of a time with getting the enamel off the wire. So we will be taking our time here, making sure we do that capacity check or capacitance check, continuity check, sorry. Oh, for those of you that were thinking I was going to make it in 1 hour, I'm sorry I let you down. Okay. Now, if we did the job right, yeah, South Utah, you got me. I think there's some more test points to test here, and there is. So verify the points. Verify the joints are properly soldered using a digital multimeter in continuity testing mode. If it has this mode, which mine does. Or check 0K. On the reverse side of the PCB, check for continuity between pins 3, 4, 5, 6, and 9. You should see 0 ohms between any pairs of these. If you do not, then there is a mistake somewhere. Most probably a failure to burn away the enamel, at least one of the L2 connections. So what is this saying? Check for continuity between... You should measure 0 ohms continuity between any pairs of these. Okay. Okay. Pins 3, 4, 5, 6, and 9. All right. Looks good. Uh-oh. Uh-oh. Oh, that's 2. No. 3, 4, 5, 6. Okay. So 3, 4, 5. Okay, wait. 3, 4, 5, 6. Am I looking at this right? No, I'm on the wrong board. Ah! I'm on the wrong one. Shoot. It's upside down. Sorry. So it is this guy. We got continuity. Okay, so then we've got some bad joint we got to take care of. We're resoldering. Resoldering to kill the enamel. Kill that enamel on your wire. Okay. Give that a second to chill out. Now, while I'm waiting, I am gonna open up another beer here. I picked this up merely because I couldn't understand what I was looking at. This is the Ballast Point Sculpin, but it was called the Aloha Sculpin? What is an Aloha Sculpin? What does that even mean? Well, we're going to find out. All right, where's my meter? Come on. Wait, I'm checking for continuity, right? Am I doing that right? Check for 0 ohms resistance. Oh, no, we're good. We're good. I'm good. Why am I 0 ohms resistance? Check for continuity between. Oh, okay, we're good. Okay, so let's do that again. We're going to do 9, 9, 3, 4, 5, 6. 6 and 5, 5 and 4, 4 and 3. Okay, I'm good. All right, we got them all. Man, my solder is not going to get shaky. I've got the hands of a surgeon for soldering. I couldn't actually perform surgery. Come on. Okay. Well, we just got a lot of toroids and then now just parts to install for making connection. Richard, K04OBR. I am what some would call an elder millennial. I was born in the very early 1980s. Yeah, I don't know why that's called an Aloha Sculpin. Doesn't taste any different from regular Sculpin. All right, we're moving along. Oh, this is the big boy winding. So let's consult our card here. Woo! Hold on. So this guy is made of higher gauge wire than all the rest of them, and that's what's being referenced here. This is L14, which goes right here. Okay. That guy's not going anywhere. Similar kind of thing where we still have enamel on all these guys, so we're going to have to make sure we're giving it enough solder, giving it enough heat, and paying attention enough to that enamel to make sure it's coming off. Well, I can see a lot of sizzling on that enamel on this part right here. I'll seize it. Here we go. All right, that's probably good enough. Okay. All right, so now here's all of our low-pass toroids that are wound up, and that's for the multi-bandedness of this radio. So we're just locking these down. We're going to knock the rest of these out, and that's primarily what's left to do on this radio is just knock out all these toroids, except for the trifilar. That's right. Now I understand. I was saying it, I think, correctly, but trifilar. Yeah. Thank you for everybody that commented on that. All right, so here we go. Let's go to L2. Is this guy? Come on, L2. Okay. This is L3. Let's solder these two. They're kind of fiddly. All right. Making some good progress here. We're definitely hit the hour, but I think I started building at 5:20. Well, a little bit before 5:20. So I think we actually are close to hitting the actual hour of build time pretty soon here. All in all, a pretty straightforward build. I will mention that I probably spent about 2 hours on those toroids, and I was not doing it, very proactively. I was trying to pay attention to, my loops and all that stuff, but I was watching YouTube videos in the background. I stopped multiple times to, recount the toroids and be just really, really sure that we were good. So I'd argue you could do this about 4 hours. That might be a little sporty for some folks. The toroids probably takes this outside the realm of most new kit builders, I'm guessing. Just my thoughts. And if you need any soldering equipment and you're thinking about taking the plunge into building some kits, check out my Amazon store because I have a bunch of stuff listed. All right, what's next? L4 is right next door, so we'll go ahead and do that guy. Okay. L6. Might as well just keep. Let's see if we can knock out a couple more of these. Maybe we'll do them all. Oh. There's solder in that there hole. Well, I didn't want to see that. That's not good. Yeah, so they got solder dripped over. I see it. I see it. Okay, hold on. So I'm using a solder sucker. It's a plunger with a push button. I'm going to open up this hole. This happens. This happens when sometimes you got close proximity. Yep, open it right back up. So put the plunger on one side, take the tip of your iron and touch it right there. While it liquefies the solder, push the plunger, sucks it right out. And I just open it back up. That's what you got to do sometimes. And sure enough, yep, there we go. We're back in business. Pretty good. Okay. Let's see. What's next? L8. Okay. And L10 is the last. So we're down to the last toroid is the trifilar, which I've already pre-checked out, but I'll show you how I did it when we get to that, which I think is probably going to be the next one. So hang tight for that. Oh, what the hell? That's pretty bad. What's going on there? Okay. I thought I had a USB-C soldering iron already listed in there. If it's not, I'll correct that. But thank you for that. I do have a couple of USB-C soldering irons that go in my kit. I've now largely replaced my standard, I guess you could call not standard, but my butane soldering iron. We can stop the poll too, because boy howdy. Actually, it's pretty split. I can't believe you guys had that much faith in me. Well, thank you, first of all. Hold on. Let's take a little breather here. I'm sweating a little bit. I'm going to get some water. Man. IT guy asked, am I still using the Morcerino? Yeah, I do. Why is it still showing? Now let's make a new poll. But will it work? Yes? No. There you go. There's the new one. All right. Hey, you got rid of the pulse gun. Oh, I guess it's back. Oh, well, whatever. I was pretty close, James. I slowed down a little bit though because I was talking to everybody in the beginning, in the opening. But yeah, it happens. Slowing down, man. Slowing down. Let's get this all soldered up and get on our way here. So a lot of what I'm doing right now, oh, you can't see it. There you go. A lot of what I'm doing right now is heating up the enamel. That's the big action that I'm doing more than anything. That solder's already fully melted. It's just a matter of getting the enamel off the wire at that junction spot of the component so that we make good electrical connection. Sometimes I go in there and kind of take the iron tip, rub across the top of the wire, see if that opens it up a little bit. I'm generally counting that the heavy blob of solder that I'm putting down is going to be enough to get that enamel freed off of there and melted. Like a soap. Now, something this radio, as I'm thinking about this, the radio doesn't give you a lot of information on how it's feeling. You're largely depending on your software for controlling the radio. You only get a status light in that LED light that's on the front of the radio. That doesn't give you a lot of info. So I'm kind of curious how this is all going to go down. Those are pretty all right. Those are okay. This one could be a little bit better. This one's a little loose. That one's good. That one's good. They're okay. They're fine. I'm not going to redo them. All right, trifilar time. So if I understand correctly, yeah, so there you go. See that? So let's get our friend here. Where is... So I took a bunch of the wire and I coiled it up. You can see it. It's all twisted. And then that got me a relatively decent length, about 2.5 feet of wire. I missed a solder? I did. Thanks. How did I not see that? See, chat, you guys are the best. Perfect. Thank you for that. Hey, Dave, thanks for the super chat. Says, first testing session administered last Sunday, 5 techs, 2 others upgraded general. Almost as exciting as taking the test myself. Hey, bud. That's great to hear. And so, administration. Yeah, so you're doing the VE thing. Awesome. Well, hey, thanks for giving back to this hobby and making sure future generations are out there getting ham radio licensed. All right, so our trifilar friend here goes like that. Basically, what you're trying to do, and you can see it in the image, is we want the wires to be kind of like a bug. You know, the front two legs should be the same wire. The B leg should be the same wire. W4O. So we're gonna double check these wires, but I'm pretty sure we're all good. So Ron asks, "Hey, what happened to that solder pot, Josh?" It's hot, Ron. It's the middle of summer, and that solder pot is like, I don't know, Soviet bloc communist era heater. You'd use that in your winter cabin to keep you warm. That thing puts out so much heat that, like, the last build I did, I was sweating. I could not use it. Oh no, it's not that it's not the right tool for the job, buddy. I wish I was just using that. I'm telling you, they're fantastic. It's it's too hot. At least the one I got. All right, let me show you another handy tool here. So we're gonna check each one of these legs. Although I've already done this, but I'm gonna do it for the sake of video, just so that you guys can see it. So I'm gonna go back to my check here with the digital multimeter, and to make my life easier, trying to like hunt down this trifilar toroid is not worth the time with two probes. So I take an alligator jumper, take that jumper, take the probe all jumped up, hook it on the leg here, and then I can just hold the jumper and figure out, where is it? There it is. Okay, so we're good. And go to this guy, hold it, good. And again, we're just making sure that our legs are spread out appropriately. Oh, come on. Good enough. So there you go. So they're matching. And I use little alligator clip jumpers for that. I find these just invaluable, particularly if you're trying to work on a kit and you're not gonna be that precise where you can go in with two fingers most of the time. You're gonna need something, another set of hands, or something that removes a hand, like alligator clips. Alligator clips are very, very helpful for this. All right, so we're ready. We're ready to take the plunge into this trifilar. And where does it go? It goes right there, and you can see you got your A, and A goes to A, B goes to B, and C goes to C. So if we take our little legs here, I've already separated them. This is going to be such a pain. Oh my god, I can't tell you how annoying this is. Okay, let's get these guys lined up. Good. Let's get these guys lined up. Okay. Woo! I got it. They don't want to go in smoothly. All right. Soldering time. We're almost done, guys. Oh, I gotta. Well, that's not good. I have a leftover capacitor. I skipped one. We're gonna have to go back for that guy. That lost soldier. I was wondering where this hole was for. All right, come on. all really close to this IC here that I'm trying not to melt, so I'm taking my time not to overheat the area. Okay. Let's see how we did. We got another test spot here. Oh, hey, there we go. Sorry, missed the super chat. Appreciate it. Amran, good luck. It'll do the business. Thank you very much for the super chat. $19, man. Thank you so much. Appreciate that. That's almost part of the cost of this kit. All right, what's our test points? Test points. Okay. So for this one, there are numerous SMD components. Yes, I know. So the SMD, the surface mount components that are all right here, very, very close. So really be careful. You can toast this IC. Be really careful with that. Once again, my method involves the iron, plenty of solder on the joint for at least 10 seconds to make sure. Yeah, that's what I did. I like it. I like it. All right, let's do the capacity or the continuity. Photo right shows the trifilar. Check. You should check your continuity between each pair of AA, BB, CC, and the triplet of IC pins 4, 7, 9, and 3. Okay. All right. So let's do that first. We'll come in here on the pairs. Good. 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 So good news. We made good electrical connection at least there, but we're going to check boy, what are we looking at here? Holy smokes. So that's this guy. This guy. Yeah, buddy. And this guy. Yeah. We got it. Heck yeah. All right. So let's go back and check that capacitor really quick. Trim this up a bit. All right, so what did we miss? Well, I got this little guy. It was hidden. This is the 181. And I think it goes right there. So let's go back up a step. Test. Okay, good. Now I've still got audio on my end. What is it? 181? What do we call that? Yeah, 181. All the way back up to the top. Oh my god. This is taking too long. Come on. Nope. Almost. Nope. Almost. 181. It was. I missed it. It's right there. Okay. Well, good thing we got really long legs on this bad boy because he's got to go through this whole mess. See, this is why you do this. You try to do all these guys right up front. So drop him in. Yep, just like that. Easy, easy, easy. I don't know. No, I'm not going to say it. I'm not going to say it. I'm almost jinxed myself. I almost jinxed myself here, guys. Okay. LED time. All right. The only indicator we get. And where are we at? Oh, way too far. Stop. Stop. Please stop. Now we got the easy stuff left. All right, what'd they do to this LED? Short lead. Okay, so that's the negative. The short lead is the negative lead. So they're coming out straight from this. It's bending right out of the short lead. Well, what is an LED? It's a light emitting diode. So there is polarity to a light emitting diode. You can see that this lead is a little bit longer. That's the positive. So it looks like they're taking the negative lead and they're bending it straight away from the body. straight down, straight down. And then they're taking something like my needle nose pliers here, and they're holding it, the positive lead, and bending that down to give it like a 90-degree turn, which I'll put on the little board there. You can see that, right? Can you see that all right? You can see that. Great. And that guy goes right here. Like so. You can see it just off the chat. And if we did it right, it's supposed to go right flush with the bottom of the board. Okay, excellent. I can do that. There we go. Flush it is. Now I'm positioning LEDs is always kind of, we got it pretty good. Yeah, that's pretty good. I'm gonna go with that. All right, let's pop it into place. Where'd my solder go? I didn't go through that much solder already. There it is. Yep. Okay. Balanced correctly. Good like that. Now we're going to take our, let's see what's next. Ah, and that's it. Wow, we're down. Guys, we're down to the end here. I'm going to loosen this up a little bit. I'm going to try and rotate it onto something else, like right there. If you'd like to make a contact with me on this bad boy, consider joining us on the Discord after chat, where I'll be coordinating. I likely won't run through the setup on it, but actually T.O. could probably tell us in the chat. T.O., what radio is the setup for WSJTX? It's a Kenwood, I know, but I can't remember what to tell folks to use. So this is your RF jack. Maybe this is your RF jack? What are we doing here? By the way, if you haven't decided fully on this kit, you know, consider downloading the manual. That's like the best way to do a lot of this stuff is just go check it out. Check out the manual, man. That'll also give you explanation on its use and function. In this case, you know, it's WSJTX, so or it's a digital device, so you're gonna have to. This is a loose boy, so here we're gonna have to come back for him. And there's our USB. And I straightened out those pins. They were really screwed up. All right, guys, we're almost there. Thing to keep in mind when you solder big things like this is you can come from underneath and hold the part. Highly recommend you do that. All right, Joe, thank you for that. It is a Kenwood 440. All right, we're going to go in here, and I'm going to attach the RF lines. And then start just dumping solder onto the actual connector here. These big connectors usually require a ton of solder. This BNC is not that greedy, though, so we're good. Okay, there's that guy. There's an audio jack, which I didn't know there was an audio jack. I'm kind of curious what that does. We're going to have to look into that. It has slightly grabby little legs. Now, for those of you that may not be hitting up the after chat, don't worry. I'm gonna show you this at least, hopefully trying to power on. But if it doesn't power on, well, then you're gonna have to join the after chat to figure out if we can get it running or not. But I don't know. So far, it's pretty smooth. Come on, Sonner. There you go. That USB was real. Okay, so for this guy, so I don't know if you've seen me do my little crab claw thing that I've done. So I take my hand There's no parts to bend here, so you kind of have to like hold. I'll take my pinky and hold the part into place. So I'm literally holding the pinky, holding the power adapter with my pinky. Then I'm going to come in and apply heat and then hit it with the solder with my thumb and forefinger. And there we go. Locked it into place. Looks pretty good, but now that I've got a little bit of solder on there, I can come in and soften it up a little bit. Let it harden. Good. I call that the crab claw, I guess. I don't know. Okay. Guys, we've got an assembled QDX. I don't know if it was assembled correctly. I don't know if it's going to work, but we've got one. It's done. So what do we do now? Well, let's give it the beans, as it were. Okay, let me clear out a space here. I've got a nice little, yeah, see, this is a mess. Got a nice little County Com trivet, or not trivet, cup holder. So what do we need? Well, we need a power source of some kind. This is the Jankopotomus plug. Here we go, guys. Let's see, what time is it? Under 2 hours. So assuming you built those toroids, got myself a Bio-NO battery right here. Assuming you built those toroids, it took me an hour and 20-ish minutes to build it, I'd say. This is a USB cable, Josh. What are you doing with that? So we should see that light come on, right? Is that what we're looking for? Let's see. Let's see what this says. Does this say anything? Optical. Oh, we will put the tape on for the enclosure. We don't want to short that out. Install the top screws. Yeah, it's talking about the enclosure. I will do that on the after chat, I think. The importance of this technique. We no longer need complex. Yeah, what am I supposed to do? Just plug it in? Is that it? No, Joe Husker, good question, good point. But no, they include up to 13 volts with the modification I did. I think I can just go straight into this bad boy with some power. Whew. Here we go. What's the pull at right now? Oh, pull is at 83%. Yes, that it's going to work. Wow, okay. So I guess we're looking for the LED light to turn on. Joe Husker, yeah, how did you feel about that winding? Has it been good for you? Let's get it nice and focused. Yeah, buddy. Who said that? I personally, and 0HR, I personally hate the expression, let's fire it up. Yeah, I can see that. All right, I'm gonna... Oh, baby! I don't know if that's good or bad, but it's something. We got a light. Is that good? Is that bad? I don't know. Okay, so... All right. We'll do one more thing. We'll do one more thing, guys. We'll do one more thing. All right, everybody, hold on. Let's unplug it. No, you know what? Can we just plug it into my computer like this? Oh. Come on, buddy. Okay. Hold on. What does that mean? No smoke and blinking lights. Is that good? Is that good? Is that good, guys? Is blinking lights good? Let me go back to me for a second here. Okay, good. Let's pull up device, because we should see a device manager now. Or a device manager. We should see a device. Even one that's like busted is fine. Like doesn't have the drivers or whatever. I can work with that. Okay. I'm not sure how I feel about this. Let me go back to this guy. This one. There we go. And let me add a window. So here's my device manager. So hypothetically, if I unplug this guy right now, it should disappear. So I'm going to unplug it. Did I lose something? I did! It was COM port 12! It works! It works good enough to move forward to the after chat and say, c'est la vie. So now we should see a COM port show up. Oh! Where's COM port 12? There's a COM port 12! Where'd 12 go? Where's 12? Hold on, let's unplug it. Okay. Make sure we got good connection. Flashy, flashy. Ah! There it is! USB serial device 12. We got it. We got it! Yes! Absolutely excellent. So, I totally, and boy, am I think I'm a little hot, guys. I'm a little hot. I totally underestimated run the test built into the firmware. Oh, Don, let's do that in the after chat. You can tell me how to do that. Let's close the poll. Boy, I appreciate the faith you guys had on me there on that one. So let's see how we ended up. 83% yes. Wow, thank you so much. So I think what we're going to do is we're going to wrap this up. We're going to go hang out in the after chat. Remember, the after chat isn't just about me dinking around with QRP kits. We're actually going to answer your questions and have some fun. And that's primarily why we do it, is to answer ham radio questions. So if you've got some time, feel free to join us out there. I want to go back to the web here because I'm not affiliated with QRPLabs. I'm not. They are one of my favorite QRP manufacturers, though. There's 3. QRP Guys, 4 States QRP, and QRPLabs. Make some of the best QRP ham radio, not just radios, but QRP gear that you can get your hands on. Highly recommend their stuff. Now, I was going to say highly recommend this build, but the QDX it's going to be it's a certain flavor profile. You're going to have to do digital modes with it. So that might not be for everybody, but that's okay, because if you don't want to do that, you can get a QCX Mini, which is, boy, could you imagine a smaller picture? Come on, dog. There you go. QCX Mini is a CW mono band transmitter, and there's a couple of mods for it. There's actually a couple of different types of radios. They have just the QCX 5-watt. That's a multi-band job, if I remember correctly. This is $50, man. And let's go back to the Mini. $55 for the Mini. Really, really cool stuff. And the really, really good radios. Of course, it's not going to be like comparable to a 705 type of thing, but if you're interested in getting into CW, I'd recommend a QCX Mini. Maybe get yourself one on 20, maybe 40. If you're somebody who's awake during the day and does ham radio during the day, 20 is probably where you want to be. But you can also start considering some of the higher bands as we get into the higher side of the sun cycle. So yeah, I think I'm going to take my at least partially working radio and go on over to the after chat. I will be cyber streaming to YouTube and Twitch, but I want to wrap this up so that people can go about their business. We do have a working radio. I was successful. I'm happy about that. It means a lot when I can actually complete a build. You know what? E83IEK. I like doing kit build videos. I like doing it. I don't get a lot of views on my kit build videos. So anybody watching this, if you enjoyed this, give me a thumbs up, because honestly, this is more of a labor of love than my live streams. My live streams already don't get much views. I could just make 10-minute and 20-minute long videos and just focus on that, and I would I'd get way more views than I do now. But I spend a lot of time preparing for the live streams, and the kit builds are the least popular. The least popular. So if you enjoyed this, I would love it if you gave me a thumbs up. All right, guys, we're going to Patreon. Want to say a big thank you to you guys, because you allow me to fool around, have the tomfoolery to do a lot of this stuff. So thank you all, and hopefully people watching this after the fact, it's helpful. I'll give you my final thoughts on this. The toroids are no joke. The toroids really are no joke. It is definitely the hardest part of this kit, but it's not insurmountable. It is something that you fully have to understand what you're doing before you do it, right? And to be fair, I haven't even transmitted on this radio yet. We're gonna wait to see if it actually transmits. But they are no joke, and you do need to take your time with them. That's the hardest part of this kit. Again, if you want something easier to start out on, QRPLabs isn't the easiest kit radios to build. Any of the, well, 4-states QRP, the crickets are probably going to be the easiest. And then you've got QRP guys with some of their antenna kits are definitely easy. 4-states QRP has a couple of other QRP kits as well. If you're super remedial, I would consider checking out the 4-states QRP dummy load. That's a really cool kit because it actually will illuminate for the power that you're sending into the dummy load. Still QRP. It's a QRP dummy load, but really cool. So, all right. That's pretty much going to do it. Next week is patron picks. The patrons have already spoken. Thank you, the homebrew crew. The patrons have spoken. We will be doing something related to software-defined radios. Maybe along the lines of what projects you can do with software-defined radios. And I'll talk about projects I've done, where to go to find more information on projects, like what can you do with an SDR, what fun is out there. And so that's likely what we'll be talking about next week. Guys, thanks so much for watching the Ham Radio Crash Course. I really appreciate you did that. And I'll see you on the Discord if you're going over there, okay? I'll play you out with some memes. See ya. That was a fun build. Yeah. I'm good. That's a good one. Not for the faint of heart. Not an easy kit, but a good one. All right, guys. I'm going to flip this car around, start heading back in the other direction, simulcasting to Twitch and YouTube for the Ham Radio Crash Course.